Hi students. Today I'm going to lead you through some guided notes on density. So let's get started. So I want you to think back to what you know about density and think back to maybe 6th grade, and we'll think about the definition. So density is, it's kind of how compacted molecules are. I'm going to put how compacted, how squished together, if you will, the molecules in a substance are. So if I write it, you write it. So how compacted they are, or we could say how much stuff, or we could say matter, right, is packed into a space. So it has to do with packed into a space. So it's how much matter is packed into a certain amount of space. And so as you might recall, density is mass over volume. Now, I don't know if you remember things like this, but I always remember it kind of like this, right? Like a heart. So you have density equals m over v, mass over volume. So nice little way to remember that. So remember, and the density of an object, that's a physical property. So when we were talking about physical and chemical properties, when we learned about chemistry, density is a physical property, and actually it determines if something floats. So when you're younger, you talk about density and things floating. So buoyancy, B-U-O-Y-A-N-C-Y, I think, determines buoyancy. So if the density is greater than 1, something sinks, and if it's less than 1, it floats, because 1 is the density of water. So that decides if something goes up or down. To the comparison of the densities determines if something goes up or down, right? And so this is going to play into weather. So we could say comparison of density determines if something goes up or down, I'm going to say. Right? So if something is more dense, so we can visualize density like this. I'm going to draw a box and just pretend that these are the little molecules of whatever matter this is, right? And so if this is more dense, it's going to sink. And if something is less dense, it's going to rise. And this is what we have when we have helium in balloons. Then that's also, the helium is less dense than the air surrounding it, and therefore that allows the balloon to go up. And then if something is more dense than, say, water, then it's going to sink down. So now we need to learn that, I'm going to change colors here, that warm air, remember, there's more kinetic energy. The particles are beating against each other and moving, and it is actually less dense because of that kinetic motion. The warm air has more molecular motion. And so those particles are beating against each other, and they can't get as close together. On the other hand, we have cool air, or water, it's not actually necessarily air, is more dense. And so it tends to sink. So when we're thinking about density, low pressure, so we talk about air pressure a lot in weather. So when we talk about low pressure, we're actually talking about less density. So if you think about, say, you've got a basketball or something like that. Say you've got a basketball here. I'm going to color in this little basketball. Right? If your basketball is low pressure, then there's less air in the same amount of volume. So you've got this low pressure. So areas of low pressure we represent in weather with an L, and areas of high pressure we represent with an H generally. So when we're talking about the movement of pressure, we have air moves toward areas of low pressure. Right, because things are kind of equalizing. You can imagine if, and we use this example, I think, with particles when we were talking about in chemistry. If you have a lot of particles crammed together, then their natural instinct or their natural movement is going to be to spread apart. And so, again, if we have an area of high pressure like this, say we have an area of high pressure, then, and it's not closed in a box, but if we had an area of high pressure and an area of low pressure, then the area of high pressure, the pressure will move toward the low pressure to kind of equalize. So we can imagine, so when we have low pressure, we have movement toward the low pressure. And high pressure is the opposite. If something is in high pressure and it can move freely, then that high pressure is going to dissipate and move toward the area of low pressure. So high pressure, we have movement away from. And so pressure and density are definitely related. And that's all we're going to cover in this little mini lesson.